Hey, hi, good morning, everyone. Let's start. I'll share my screen. Right. So, yesterday we were discussing this code, and we were trying to predict whether someone will leave the company or not, depending upon their experience, previous year rating, number of hours they are working on, whether they have met any work-related accident or not, uh, right? What was their department and so on, right? Just for an example, from HR department, we have the highest chance of someone leaving. And from the management department, we have the kind of lowest chance of leaving. Right? So it looks like that, okay, yeah, this can also be a good variable. Now, what happens is that whenever, okay, this is a question to you guys that how many unique values this categorical variable has? The department variable, how many unique values it has?
Seems to be 10 on the screen.
Yes, right. So there are, say, 10 unique categories that we have. So related to these 10 unique categories, how many columns will get created when we will
9.
do one hot encoding?
9.
9, right? So now we can see that, uh, related to this department column, there will be 9 new columns will get created when we will do one hot encoding. Right? Now, if someone wants to reduce the number of categories, okay, so one way can be that we can combine those categories which have similar rate, similar percentage of people leaving the company. So maybe, sales, this technical support, this is technical support, IT, product management, marketing. I can keep it as a one category. Similarly, maybe accounting and HR both has comparatively high number of people, percentage of people who are leaving the company. So maybe these two can be combined into one category. And then R&D and management can be combined into one category because both has relatively low percentage of people who are leaving the company. Okay. So whenever you have a column which has a lot of unique values, and you feel that that column is gonna increase the number of columns that we have after doing one hot encoding, this is how you can combine it. The categories with similar, let's say here, percentage of people who are living can be combined together to make one single category. Okay, let me run this again.
Yeah, Puneet, can you share
Mm-hmm.
the files again?
Sure. Right. Okay. Cool. Now, what I'm doing is I'm doing dummy variable creation. Okay, this is all the variables which are integer. In the next part, what we are doing is we are dropping one of the variables. Okay, you can also do here you can write drop first equal to true. That will also work. Or if you want, you can choose which variable you want to drop. So here, for example, I'm dropping salary medium and department technical. Okay, so close to 19 variables we have now. Okay. Finally, what we are doing is we are uh, dividing the data set into two parts, one with the target variable, this is our target variable, and one with the all the features, all the input variables. And in the next part, we are splitting the data set into test and train. We are keeping the test size as 30%. So by default, the train size will become 70%. Okay. So training data set will have 10,000 rows and test data set will have around 4,500 rows. And finally, very easy part, we are saying that we want to use decision trees in the data boost. An estimate equal to 20 means that we want to create 20 such trees. Okay. And random state equal to 100, which is a random number. We'll run this. See, the training data accuracy is almost 100%. And accuracy for test data is 97.5%. So this will be our model accuracy, 97.5%. Right? Here we have not tuned for the number of estimators because in general, more the number of estimator, better it is. Okay, but what you can do is using maybe grid search CV, you can try out different values of an estimator, and then you can see which one is giving you the better accuracy. Another thing that you can do is that a lot of people do, they create a loop. Okay, now listen to me carefully once. Can I write a for loop here, right? Can I write a for loop here? Sorry, not here. Can I write a for loop here, right? Let's say 100 times, right? And this thing will be taken as an input. Let's say like this. Okay, so n will first become 1, and then will become 2, and will become 3, and will become 4, and will become 5. And then you can have a variable which is storing uh, all the accuracies, right? Then we can have one variable which is storing all the accuracies, and then we can plot that, okay, when I'm keeping an estimator as 1, then what is the accuracy? When I'm keeping an estimator as 2, then what is the accuracy? And then you can create a graph between the number of an estimator and how the accuracy is changing over the period of time. Clear?
Yeah.
Right. So because that is also another thing that the people use very frequently. They just plot with number of trees to see what is going to be the accuracy. If I will increase the number of trees to 2, 3, 5, 10, 15, and so on. Any question? Okay. One more thing that you guys can do is that in logistic regression, we also did classification. For decision tree, we also did classification. Random forest, we also did classification. And now in AdaBoost, we are also doing classification, right? So the data set that we used for logistic regression can be used here as well to see what is the accuracy that we are getting using AdaBoost versus what we were getting in logistic regression. Similarly, the data set that we use for random forest, that data set can also be used again here to check what is the accuracy that I was getting for random forest versus what is the accuracy that I'm getting for AdaBoost. Okay, so it will give you some idea that, okay, now I have 4 data set related to the 4 machine learning techniques that we have learned so far. Let's see, you know, what is the accuracy on each data set for different machine learning techniques.
Puneet,
Mm-hmm.
yeah, I have a question. Yesterday you were telling about 10% stock data, right? 10% accuracy and 80% accuracy.
Mm-hmm.
Yeah, so but usually stock recommendations will be like just buy or like after you buy you sell it. So in that case, we how can we do the negation of it? Like if I have 1 lakh, I will either buy or I'll say
I will not
I'll
buy.
just I'll just hold the money. So
No, actually, in stock market, you can also sell first and then buy later.
that's intraday trading. That's different. But usually,
Not exactly. First of all, that was just an example, right? The main point is
okay,
that was
and
just a, yeah,
yeah,
tell
that
me.
was just an example. I admit
Hmm.
that.
Mm-hmm.
And my question is, there will be
Hmm.
cases like this, right, where we can't take the
Mm-hmm.
negation. Suppose if
Mm-hmm.
I'm predicting the car price, I predict it as 10 lakhs. If it is wrong 90% of the time, I
Mm-hmm.
can't take it in the reverse case, right?
Right, right. But this is true only for classification, right? For classification, you can give me any example. Like for example, I'm using it in bank. That
Mhm.
in bank, whether the person I should be giving loan to a person or not, right?
Yeah, yeah, for
You're
classification it works, but
so this is
that
only true for
example I
classic.
got confused.
No, no.
Actually, that buying we
Okay, okay.
can't do negation, right? So
Right,
that's
right, right. I agree.
okay.
But for other classification, it is true, right?
Yeah, yeah, yeah. That's
Okay, okay.
that's true. Yeah. Thank you.
Sure. Okay. Any question before we move on to the next machine learning technique?
Yeah, Puneet, you
Mhm.
told that for using for loop. So in normally in general, how
Hmm.
used or not? Because I normally we will not use for loop, right? We'll
No,
use
no,
for
we can. I have used it myself a lot many times.
okay.
In random
Uh,
forest also, for an estimator, I can plot. See, it depends upon what is the runtime. If the runtime is not much, let's say in this case, the runtime is not much. For one iteration, how much time it took? Like 5 seconds. So if I will do 20, 30 iteration, max to max, it will run in 5 minutes, right? So why to try only few values like 5, 10, 15, 20, right? When I can try each and every value, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But yes, if I know that the runtime will be high, then in that case, I will be using grid search CV. I will just try out 10, 20, 30, 40, 50 to see which one is working out the best.
So few
Hmm.
cases it will take longer time, right? So how we
Yes.
can optimize because that is also there, right? Because I have seen few models that is running for longer time for
Mhm.
training.
Mhm.
So
See, you can do a few things to optimize it, but not too many things that we can do. Let's say the data set is big, that we have a lot of rows, a lot of columns. It's going to take time. That is one thing. Second thing is that we can reduce the data set. Sometimes, especially with the traditional machine learning techniques, uh, beyond a certain point, it does not matter how much data set you have. Like, for example, here we had 15,000 rows and we got 97.5% accuracy. Even if we had 1,50,000 rows, maybe this accuracy will change to 97.6%. Now just imagine if I had 15 crore rows, this 9.6 might change to 9.7 or might remain 97.6 only, right? So point being is that a lot of data does not mean we will have very high accuracy. Okay. All like if I'll take it from a student's example perspective, it is more or like that it is important that I will be giving example to my child or to student to teach him addition, right? I need to tell him that 2 plus 2 is 4, 4 plus 4 is 8. If I will not tell him this, he will never learn addition. Okay. But at the same time, let's say once I have given 100 examples, or 150 examples, or 500 examples, do you think it matters that he will learn addition better if I will give him 500 examples versus if I will give him 5,000 examples? Maybe you will say that yes, there can be some marginal change. If you will give him 500 versus 5,000. Now, versus 5,000 versus 50 lakhs, I don't think so. You got my point? So learning can happen to only certain extent, right? Let's say, for example, I have a model which is trying to classify a image into elephant versus ant, right? Now, maybe if I'll show my machine learning technique only 100 images, that might not be enough. So maybe if I'll give him 10,000 images, 10,000 images should be enough for machine learning to identify what is an ant, what is an elephant. Do I need their 1 crore images? I don't think so.
Okay.
Right? Yeah. So there what we can do is we can reduce the data set, right? At least our first iteration or first few iteration can be done on a small data set instead of doing it on the whole data set. One problem which happens is that with most of the people, that if I was given 10 crore rows, I will use 10 crore rows from machine learning perspective, right? Actually, it is not needed. My first iteration can be on 50 lakh rows. I can make multiple iteration on 50 lakh rows. And once I'm confident, I can do my final iteration on 10 crore rows as well, just to see that whether everything is making sense or not, even on the big data set,
Okay. Yeah,
right?
because
So,
I was using almost 20 lakh rows for training. That's why I wanted to.
right. So there you can maybe, let's say, use 5 lakh rows, right?
Okay.
And then they make all the iteration. And once you have done all the iterations, you can just see that, okay, if I will increase my data set from 5 lakh to 20 lakh, are my insights changing or not? Ideally, it should not change. But can it change? Yes, it can change. Then we will see.
Okay.
Right? The same goes for, so this is just one part where you are reducing the number of rows. Second part is the data set can also become bigger when you have a lot of columns, right? So what we can do is we can try to reduce the number of columns as well. You must have seen in logistic regression, right? With each iteration, we get to know, first of all, VIF is there, okay? Using VIF, you can see that which variables are actually useless, right? Any variable which has the value of more than VIF more than 5, you can remove it. That is one thing. Second thing is later in the course, we will be studying PCA, principal component analysis, that can also be used to combine different variables. Then we can use our a little bit common sense as well, that, okay, this will not be useful at all. Or maybe what you can do is you can split the data set and run for each variable, you can run it separately and see whether this variable is coming out important or not. Point being is that we can do multiple things to reduce the data set. And if you reduce the data set, most of the time, the runtime will also go down. Other thing that you can do is now from a machine learning perspective. Okay. In general, decision tree is faster as compared to logistic regression. Logistic regression is faster as compared to random forest. Random forest is faster as compared to AdaBoost. Okay. So that's something that we can also see. Maybe we can start with those machine learning techniques which take less time to run, and then slowly we can move towards those machine learning techniques which takes more time.
Okay.
Okay.
Sir, I have used like 3 to 4 data sets now. Every time I have got the accuracy of random forest more when compared to AdaBoost classifier.
Mhm. Then it is nice, Sumit. See, there is no guarantee which one will come, which will always have the higher accuracy between AdaBoost and random forest. It can happen that the random forest has better accuracy as compared to AdaBoost. And even in boosting, there are multiple technique, Ada, XZ, light GBM, and all of that. So in general, we try all and see which one is giving us the better accuracy. But yes, it can happen that random forest have more accuracy as compared to AdaBoost. It can also happen that maybe logistic regression have better accuracy as compared to AdaBoost or random forest. But in general, AdaBoost
Mm.
has highest accuracy, followed by random forest, followed by logistic regression.
Okay. So one more question. Like you told about the VIF, right? But if
Right.
VIF works only for the linear regression models, right? Not for the non-linear ones.
It will work for logistic regression as well, because for logistic regression also, uh, we we in the backend it is just linear regression only.
Yeah. Sorry. What I meant is like
Uh,
non-linear models. I mean, it's not suitable for non-linear models, right? VIF.
it is direct. It will be direction. So you are right. First of all, that it will not be suitable because it checks the linear relationship between variables. That's one thing. But what VIF is doing, VIF is seeing whether whatever variability in the data is there, okay, which is being explained by this particular variable, can it be explained by other variables or not?
Okay.
Okay,
Okay.
right? This is what we are seeing. In
Yes.
VIF, we check whether this particular variable can be predicted by other variables or not. If it can be predicted by other variables, then this variable is not needed because this variable is not independent.
Okay.
Right?
Okay.
Right. So
Mm.
if you will go by that theory, actually you can use VIF almost everywhere. But yes,
Okay.
the kind of impact that it will have on linear models versus it will have on non-linear models will be a little different. But I feel it is. I've never tried, but I feel that it will be more or less same, right?
Okay.
Because we are only dropping those variables, the variables which can be explained by other variables.
Okay. Okay.
Okay.
So for nonlinear models, like what we can use if PIF is not suitable, is there any other method?
No, first of all, I will not say VIF is not suitable to me. Like my theory says it should be suitable, right?
Okay. Mhm.
Second thing is that the other thing that people take call is based on correlation, right?
Okay.
Check whether correlation is there or not. Chi-square value, if you have a classification model, the people check chi-square value, whether this particular variable is related to your target variable or not.
Okay.
Okay.
Puneet, that code
Mhm.
looks very simple. Can you please quickly explain what happens in the backend? Like when the decision tree is one, when we use two decision trees, what happens? What is the variability?
Here
Yeah, yeah. So what happens in the backend exactly when we run this code?
in the backend, exactly what we covered in the theory, right? The first one decision will be, so it's like what will happen is what happens in AdaBoost, right? If you have 10 variables, the first step will be out of those 10 variables, I will be checking which variable will give me the highest accuracy, right? That will be the variable that I will be using to create the first stump, right? What is
Right.
a stump? Stump is a decision tree with
Mhm.
only one level, right?
Right.
Now, using that stump, what I will be doing is I will be making prediction on all the rows in my training data set. Few rows I will be able to classify correctly, a few rows I will not be able to classify correctly. Okay.
Yeah.
Then what I will do? Then I will calculate amount of say of this particular model. I will calculate what is the weightage. What is the formula for amount of say? 1 by 2 ln
Long
of 1 minus error divided by
error.
error, right?
Yeah.
So this will give me the weightage of the model. Now, once we will have the weightage of the model, we will know that how much important this model is. If this model will say yes, then how much weightage I should give to that yes. Or if this model will say no, how much weightage I should give to that no. The second step will be to kind of pass on the learning of this model to the next model, which is nothing but we will be changing the weights of the rows. How do we change the weight of the rows? what we do is we use this formula 1 by 2, I believe, e raised to power amount of C.
Minus है तो
No, sorry, yeah. And the previous, the old weight. Okay, 1 by 2, the old weight multiplied by e raised to power amount of C, wherever we have made the wrong prediction. Wherever we have made the right prediction, we will use the old weight multiplied by e raised to power minus amount of C. Okay. Using these formulas, we will calculate the new weights for each row. Now, the new weights, if you will add it up, it will not add up to 1. Okay. So what we need to do, we need to normalize our weights. How will we normalize our weight? We will add up all the weights. Let's say in our example that we had covered, the addition came to 0.68. Right? So we will add all the weights and then divide each weight divided by 0.68. That will give me the normalized weight. Okay. Once we have normalized weight, again we will check which all the variables are going to give me, which out of all the variables which are remaining, which one is going to give me the highest accuracy. We will take that variable and again we will create the second trait and so on. Okay, so this is what is happening in the backend. Whatever we covered in the theory, the same thing.
Okay, in the second iteration, again, it will try with two decision trees.
Not two, just one, right? In every iteration, we are creating only one decision tree.
N estimator is to, I mean, I'm talking about that for loop which you have discussed.
Right, right.
So in second iteration, we'll give that N estimator as when we give it as 2.
Then what it will do is, so when we do an estimator as 1, it is going to create only one iteration, that is one decision tree. When I will say an estimator 2, then yes, it will create two decision tree, but one by one. First one decision tree, then take learning from that decision tree, and then create the second decision tree. Okay. When an estimator is 3, then I will be doing creating 3 decision trees, but in a series. First decision tree 1, then decision tree 2, then decision 3.
Okay. Okay, and once this model is finalized and we have finalized this model, and if I have some data and I want to know the target variable, then how can I give that data here?
Yeah, just the way that we are giving test data.
Okay,
Test
so
data is not having any target variable, right?
So I just have to load that new data set from top and then I just have to run this code, right?
Yeah.
Okay. Yeah.
Just this line of code is enough.
Only that one line of code.
Yeah.
Okay.
You just need to load the data and pass the data through this line.
Okay. Because the new data set which I have, that will not have any training data, right? That is completely only the test data.
Yes, yes, right.
So I just have to run only this line of code.
Yes.
Okay. Yeah.
Okay, but there I'm assuming you might not be able to calculate any accuracy because you might not have the target variable.
Okay.
Right? Because in the new data set, in general, we don't have a target variable.
Okay. So can't we assume the accuracy would be same as the one
Yes,
which
yes.
we
We
trained?
can assume that. That's correct.
Okay.
Okay, but I'm just saying that you might not have Y test to run this code.
Okay. Yeah. Okay. Yeah. Thank you.
Puneet, can you share this code?
I have shared in the chat. Okay, I'll share it again. And I will also share it in, in the shared drive. Just do that. Okay, now let's start with yes, Deepak, we can try for a new employee as well, right? So the new data set can have only one row It can have multiple rows as well. So anything will be fine. Okay, let's start. So the next one, machine learning technique that we are going to discuss today is going to be K-means machine learning technique. Very simple one and very interesting at the same time. Okay, so I think whatever we will cover today, I think it should be easy to understand. Let's start with what kind of machine learning technique the K-means is. So we have discussed so far that the machine learning techniques can be broadly classified into two types. What are those two types?
Supervised and unsupervised.
One is supervised, other one is unsupervised. Okay, when we have supervised machine learning technique, that means that we have a target variable. And unsupervised machine learning technique means that we do not have a target variable. Okay, supervised machine learning technique then can further be classified into two parts. What are those two parts?
Regression and classification.
Very nice. So it can be regression or it can be classification. Okay, regression when you have continuous target. And classification when we have categorical target. Okay, so the machine learning technique that we are going to discuss today, that is K-means, is going to fall here. It will be the unsupervised machine learning technique that we will not be having any target. Okay, so let's try to understand it using one example. Okay, maybe if I have a graph between income and spend, right? What is your monthly income versus your monthly spend? Now, a lot of individuals will be there in this data set. Right? A lot of individuals can be there depending upon their saving and spending pattern.
Expenditure.
Right? Something like this can be there. Now, here what we want to do is I have a data set in which I have income and I have spend. Okay. And what I want to do is I want to create different groups in my data set. This group does not exist as of now. We don't have a target variable where we can say that, okay, this customer belongs to group one, this customer belongs to group two, this customer belongs to group three, and so on. We don't have anything like that. Based on the income and spend, I want my machine learning technique to create different groups. Right? Why we want to create different groups? We want to create different groups so that the similar customers can be put together. Okay. And what is going to be the benefit of putting similar customers together?
Similar things can be similar offers.
Right. We can create similar kind of policies for them. We can target them with similar offers, right? Like for example, if I have multiple products, right? Like if I'm an insurance agent, right? we will have multiple, different types of policies. Not every policy will be suited for every person, right? Each policy is created by keeping a certain group in mind. Okay, let's say if someone is there who is having very high income, but very young, so maybe there will be a certain kind of policy which I can recommend. If there is a person who is in old age, has very high income, then there will be a certain policy that I will recommend. If someone is in a young age, has very low income, then maybe a certain different kind of policy that I will recommend, and so on. Okay, so point being is that once we club similar people together, it becomes easy for the company to understand that group and create policies on marketing targeting that particular group itself, right? First of all, we'll get to know how big that group is, right? Whether it is significantly big or not. If it is big, then we can, instead of studying one individual, we can study a group. Let's say if I will try to create a group for this data, it might look like something like this. Right? This is how, in general, let's say when you do use machine learning, this is how the groups will look like. Okay, we have created 4 different groups depending upon the customer's income and spend. If I will call this group as first, let's say I call this group as first, I call this group as second, call this group as third, and this one as fourth. Okay, let's say I'm calling these groups as group 1, group 2, group 3, group 4. Now what I can do is, in case of machine learning, we call these groups cluster. So I am having cluster 1, cluster 2, cluster 3, and cluster 4. Okay, and I can divide this cluster, or I can try to understand this cluster from their spend and income perspective. Right? For example, for cluster 1, is the spend high or low?
Spend is high,
Spend
income is
is high,
Spend is high and income is low.
less.
So I have high spend and I have low income. Similarly, for cluster 2, I will have high
high
spend.
income, high
Some
spend.
high aspect.
Right, very nice. And again, this is not something the machine learning will tell you. Machine learning will just tell you simply that these belongs to group 1, group 2, group 3, and group 4. They will not comment about how they have created how it has created these groups. So you would have to observe yourself to see like why these customers are in one single group. Okay, that exercise you would have to do it yourself. The machine learning technique will just tell you that this is group 1, 2, 3, and 4. Why they're clubbed in same group, it will not tell you that. It's just that based on the variables that you have provided, these customers are similar. Okay. For 2D, it is comparatively easy, but when we have more variables based on which we do clustering, it becomes a little tricky. We need to check what is the average value for each group, this and that, trying to figure out what each group means. Similarly, for cluster 3, we have low spend, low income. And for cluster 4,
Low
low
spend,
spend, high
high income.
Now, let's say, based on the machine learning exercise that you have done, you are being able to create 4 clusters. And for those 4 clusters, by checking the average spend or average income, you were able to realize that cluster 1 is of high spend, low income customers. Cluster 2 is of high spend, high income customers. Customer 3 is of low spend, low income. And similarly, cluster 4 is of low spend and high income. Right? Now, what else we can do? Right? What else we can do is we can try to guess, right? We don't have this data, but I'm trying to guess what is going to be the age of these most of the people who are in cluster 1. What is going to be the range of their age, right? Who all have high spend but low income?
Youth.
Youth, right? So maybe I can say 18 to 25, right? The youngsters will have comparatively high spend and they will have comparatively low income. Now, similarly, if someone is having high spend and high income, which age group it can be?
Mid-age.
Mid-age. So let's say 25 to 45, right?
Yeah.
Right. So maybe this is the age group when the people are getting married, they will have children, children's education will be there, marriage, all of these things will happen. Now, cluster 3, where I have low spend and low income, what can be that age group?
Students.
Students,
Student. Let's exclude
students and not
less than
employed.
18, less than 18 per,
Yeah.
yeah. So let's exclude people who are less than 18. We're talking about 18 plus. So what age group this can be?
Less than 18.
No, we are excluding people who are less than
Okay,
18.
okay.
Like
Yeah,
retired,
senior
retired,
citizens.
senior
Retired,
citizens.
right?
the
60.
elder people.
Plus 6.
So here the people, because in general they are not working, so they will not have much income. At the same time, because they are not doing anything else, the spend will also be low. And then low spend, high income can be from 45 to
45 to 60.
60. When like your children are married off, or at least their education is complete, right? You are at a senior position now, so you are getting a good income, but not a lot of spend that you were doing. Okay. And I'm just talking about from directional perspective. Yes, there can be people in cluster 1 who are from a different age group, right? From 25 to 45. But I'm talking about the majority of the people. What will happen to the majority of people? Now, if I'm Amazon, okay, or let's say a company like Amazon, need not to be Amazon. If I'm a company like Amazon and I want to target these people, right? So what are the items or products that I can recommend? Okay, so just giving you an example, that if to the first group, the first cluster, if I will be targeting them with back to school items like books, pencil box, or your school bag or diapers, right? These people might not be interested in that. So even if I will be spending money on marketing for cluster 1, I think if you will be recommending these kind of products, they might not be interested. Okay, so what they might be interested in?
Mobile.
Yes.
Let's say
The
electronics.
affordable mobile phones.
Clothing, shoes, watches, bags.
Two-wheelers.
Okay, so let's say electronics, maybe fashion, as someone said, maybe two-wheeler, those kind of a thing, right? So if I'm doing a marketing, I will be doing marketing for these kind of products. And as someone said, maybe more affordable as well, right? Maybe the people might not be interested in a lot of branded products. They will be interested in more unique products, may or may not be branded, right? If you are in the group two, 25 to 45, your spend is also high, income is also high. Maybe I will be recommending you more branded products, right? Because these people are interested in buying clothing. At the same time, they have money to spend as well. Okay, so maybe the branded products, maybe the grocery, right? Like Amazon Fresh, for example, different kind of baby food, school related items, and so on. So if I'm doing marketing for this age group, maybe something like this I can recommend. Now, if I'm in cluster three, what kind of things you will be recommending?
Mostly based on savings,
Mm-hmm.
like best price
Medicine.
items, medicines. Yeah,
All right, very nice. So we can maybe recommend different medicines, right? Health checkup, right? And other things related to the people who are retired who might be needing it. Okay. Similarly, if you are in cluster four, this is the time maybe you might want to recommend them a retirement plan.
Vacations.
Very nice vacation. Right? So see, if we look at what we are doing is we had one data set in which we had spend and income. We asked our machine learning technique, can you please put similar customers together? Okay. And our machine learning technique said that, okay, these customers are similar to each other. These customers are similar to each other. These customers are similar to each other, and so on. But my machine learning technique will not tell you why they are similar. They are just close to each other. That's why they are similar. And that's why I'm putting them together. It will be your job then to find out, okay, let's say in this case, what I will do is, here it is very easy to look at because it is a chart, right? But what we do is, when we have a very big data set, instead of plotting it like this, I will be checking what is average spend for cluster one, what is average spend, what average income for cluster one, and so on. So I'll get the average values, and that will give me some idea what cluster one means. You will be able to see that the cluster one and maybe cluster two will have high average spend. Okay, and maybe the income for average income for cluster one will be low, and based on that I can come up with these categories, right? Then what we did, this age part is nothing but just our guess, right? Again, I don't know that, but based on the spending and the income behavior, I can guess that most probably this is going to be the age of the people. And then what was the next thing that we did? We said, okay, these are the different items that we can recommend to this each group. Right? So what we are doing is we are creating our policies, our marketing, our product design based on the different clusters that we have in our data. Okay, so this is how any clustering works. In any clustering, you will have a data set which will have a few variables. Using those variables, your machine learning technique will put similar customers together. Need not to be only two variables. You can put 3, 4, 5, 10 different variables as well, right? So using all of that, your machine learning technique will put similar things together. Okay, and then uh, once the machine learning has created the groups, it will be on you to understand those groups. The machine learning will not explain. It will be on us to understand those groups, and then whatever our purpose was, let's say, for example, in this case, we wanted to create a product recommendation model based on this. So we will be able to come up with what kind of items that we should be recommending to each group. right? So instead of taking a decision for each individual level, we are taking decision at what level? At a group level.
Group level.
Okay. Now, so I said that, in this machine learning technique, my machine learning model, what it will be doing it will be putting similar customers together. And how does it is going to identify a similar customer? By calculating the distance between different customers. Okay. Now, when we say that it is going to calculate the distance between different customers and then going to group them together, one thing that we need to remember is any distance-based algorithm which is going to be there. Okay. There are going to be 2-3 different algorithms that we will discuss. One is k-means. One is KNN. And one is PCA. All these three are distance-based algorithms, right? I will discuss more on this part like later. But all these three algorithms are distance-based algorithm, and all distance-based algorithm only works perfectly once you have normalized the distances. Okay. What do I mean by that? Let's try to understand it. Let's say, hypothetically, you are a girl and you have what we call, you are looking for a guy to get married, and there are 3 recommendations that you have from your relatives. Okay. So you have guy 1, guy 2, and guy 3. So there are 3 prospective rooms are there, out of which we need to choose that who we like, who we don't like, and XYZ, right? And let's say for these people, if I want to take the decision very objectively, I want to mainly consider 2 main things. One is, let's say, income, and one is the height. Just 1 minute. So I want to consider mainly 2 things. One is income. One is, let's say, height. Okay. Now, before we discuss any further, whenever we want to calculate any distance in a distance-based algorithm, that distance is using Euclidean distance. Euclidean distance. How Euclidean distance is calculated? If there are 2 points, this is, let's say, x1, y1, and there is another point, x2, y2. Okay. The distance between these two will be x1 minus x2 square plus y1 minus y2 square. Okay, this is called Euclidean distance. Do you guys remember? You must have done it like somewhere in 8th, 9th or something.
Yes.
No?
In 11, 12.
11th, 12th. Okay, yeah. Okay. So we calculated Euclidean distance, x1 minus x2 square plus y1 minus y2 square under root. If there is going to be 3 variables, then it will become one more, z1 minus z2 square, right? And so on. If there are 4 variables, then it will be, let's say, a1 minus a2 square, and so on. Okay. Now, let's talk about income. These 3 guys have different incomes. Maybe one is having 10,000 per month, one is having 9,000 per month, and another one is having, let me think, just 1 minute. One is having 9,800 per month, and another one is having 9,500. Okay. And when it comes to height, one guy is having maybe 168, one guy is having 145, one guy is having 170. Okay, let's say these are the income and these are the heights of three different guys. Now tell me which two guys are similar to each other. If I will ask you, which two guys out of these three are more similar to each other?
Guy 1 and Guy 3.
1 and 3.
Guy 1
1
and
and
guy.
3,
Yes.
right? But don't you think that the income for guy 1 and guy 2 is having,
Is
let's
more
say,
similar compared to Guy 1 and Guy 3.
yes, right. Then why you said guy 1 and guy 3? Why
Height,
guy 1?
because of the
Height.
height. It's because
But
of the, yeah.
but here the gap is, let's say here the gap is of 2. Here the gap is of how much? 50,
23.
60,
23.
23. Okay, 23. Here the gap was of
200.
200, and here the gap was of 500. So don't you think that this gap, like here the gap is way more as compared to what we had over here?
But we'll compare uh, the gaps only between the same variables, right? Not between the different variables.
Right, but if I'll talk about Euclidean distance, right, that is going to be the difference,
What
addition of
mean by
difference.
this formula?
Which formula?
Euclidean distance. You write.
Euclidean distance is when we are trying to see whether the 2 points in a space are close to each other or not. Okay. In any space, let's say, for example, if there is one more data point here. So if you want to check whether first point, is it more close to third point or is it more close to second point? So we do that by calculating this distance. Okay. How this distance is calculated? Using Euclidean distance. Clear, Likita?
Yeah, yeah.
Okay, now going back to these guys, right? When you guys said guy 1 and guy 3
We can
is
calculate the Euclidean distance
Mhm,
for Guy 2 and Guy 3 both. Then we can accurately say which
mhm,
of the two guys are more similar. Taking the
okay,
reference point of Guy 1 as 0, 0.
mhm, okay,
So then Euclidean distance between Guy 1 and Guy 2 would be under root of 200 square plus 23 square.
mhm. Okay, let's do that. Okay, we have I will call it distance 1, 2, right?
Yeah.
So what I'm doing is calculating distance between guy 1 and guy 2, which is going to be x2 minus x1, right? That is 10,000 minus 9,800, which is 200 square, plus this minus this, that is 23 square. And let's talk about another distance. The distance between guy 1 and guy 3. It is going to be 10,000 minus 9,500, that is 500 square. And height difference, that is 2 square. So where the distance will be more?
Calculate.
1, 2, 3.
1 to 3 is very obvious, right? This is
Yes.
going to be more. So we are saying from machine learning perspective, right? The distance between guy 1 and guy 3 is more as compared to guy 1 and guy 2. So guy 1 and guy 2 are more similar to each other as compared to guy 1 and guy 3. But does it make logical sense? Right? You guys said logically guy 1 and guy 3 are more close to each other as compared to guy 1 and guy 2.
Yes.
Right? Why that is the case? This is
Mm.
why if I'll ask that question again, Why do you think guy 1 and guy 3 are more closer to each other as compared to guy 1 and guy 2?
Physically,
Physically, but income also matters, right?
yes. I mean, subconsciously we are giving more weightage to the height compared to the income.
That is one case. Now, so we are okay. You're saying that because we are subconsciously giving more weightage to the height. Okay. We are saying that guy 1 and guy 3 are more similar. But I feel logically also, guy 1 and guy 3 are more similar to each other, because if I look at the income difference is not that much. Do you think that it is hell lot of a difference if someone is making 10,000 per month versus 9,500 per month?
Not really.
Not really, right? But physically, if I have a difference of, let's say, one person is, let's say, 168 centimeter, one person is 145 centimeter tall. Do you think it is a significant difference in height?
Yes.
Yes.
Yes, right? So in income, even a difference of 500 is not much. But in height, even a difference of 10 centimeter, 20 centimeter is going to be a lot. Why that is happening? Because both the variables have different scale. Okay. In terms of income, a variation of 1,000, 2,000 is nothing. And in terms of height, there will never be a variation of 1,000, 2,000. Right? Only 10, 20, 5, 6 centimeter here and there, the people will be.
Okay, so like we are looking at the relative difference.
Right. Yes. The problem is that here, the scale of difference, the scale of the two variables are very different from each other. Okay. So whenever we have two different scales, when we have different variables, we have different scales. Okay. So when we have different variables, we have different scales. In that case, the distance algorithm will not work. It will start failing. Okay. So we need to normalize each variable before we can use any distance-based algorithm. Okay. So always remember, any distance-based algorithm will fail if you will not normalize your variables. Okay. So we need to normalize it first so that the range of both the variables is same. Now, how do we normalize each variable?
Yeah, we did yesterday. We, took the average, then divide by each.
Very nice.
Divide that by.
That
Yeah.
is one way of normalizing. Another way of normalizing is, that's one way of normalizing, we will discuss about it. Another way of normalizing is x minus x min x minus x max. Can anyone tell me what is going to be range? What is going to be the range of this?
0 to 1. 0 to 1.
0 to 1, sure. When it will be 0?
When x min equals to x. Minimum, x is minimum.
When x is minimum, very nice, then it will be 0. And when it will be 1?
When x min equal to x max.
Yes, when it will become one thing. I wrote it wrong, and I think that's why you guys were not able to answer. This is going to be my bad. My bad. Again, I've written it wrong. I think now it will make much more sense, right? When x will be equal to x minimum, then this will be 0. When x is going to be x max, then it will be 1. Right? Right? So any variable that you will normalize, that will have a range between 0 to 1. Okay. It is different from what we did yesterday. How it is different from what we did yesterday? Because in yesterday, what we were doing is the addition of all the rows should add up to 1. Here it is not that. Addition of all the rows may not add up to 1. All I'm making sure is that each value, each individual value should be between 0 to 1. Okay, so the income will also have a range between 0 to 1. The height will also have a range between 0 to 1. And now we can easily calculate the distance. And you will see that this time height is going to have an impact whether two people are similar or not. Are you guys being able to follow what we are discussing?
Please repeat the last line, what you just said.
So I'm saying that now after normalization, right now, let's say, for example, the income in this data set, the income is varying between 9,500 to 10,000. And height is varying between 145 to 170 centimeter.
Yeah.
After normalization, you will realize that both income and height will vary between 0 to 1. Okay.
Okay.
And then if you will calculate the distance, you will see that height is going to have an impact. You will see that the guy 1 and guy 3 are more similar to each other as compared to guy 1 and guy 2. Right? Because logically also we were feeling that guy 1 and guy 3 are more similar to each other. But when we were calculating the distance, it was telling us a different story. But after normalization, if you will do the same thing, you will realize that guy 1 and guy 3 are similar to each other, what we were expecting anyway.
What mean by here normalization means?
This. Okay, changing the range of the variable. Okay, let's do just for the same explanation perspective. Let's normalize a variable. Okay, I have income. I have height. Income is the income is varying between 8,000 to 10,000. Height is varying between, let's say, 140 to okay. Now, if I want to normalize this, what I need to know? There are two
Minimum
things
and
that
maximum of the both variables.
right. We need to know the min and max of both the variables. So we will calculate first minimum. Then we will calculate maximum. Right? The same thing for these two as well. Then we will calculate, let's say, income, normalize, and height, normalize. Okay. Normalized income is going to be xi minus what?
X min 8112.
X min, let's say, okay, you're divided by x max
Max minus X min.
minus x min. Okay, see a number between 0 and 1. Similarly, this is going to be xi minus x min divided by x max divided by x min. So these values, as you can see, is between 0 and 1. Okay, so instead of while calculating the distance, instead of like using this variable, income and height, which are on totally different scale, we will be using these variables. Okay, so for any distance-based algorithm, you should always and always normalize your variables. If you will not do that, you will get a wrong answer. Any question?
So some values have come as zero also. What does that mean? Like
It means
height
nothing, but
normalization.
there the value is minimum,
Okay.
right? That there the value is minimum. That's fine. Like see, for
Okay.
example, here it is coming because this value was 8112, which is the minimum value.
Oh, right. Okay.
This is 140, so this one is 0. And for maximum value, you will see the 1. This is 1 because 9978 is the maximum value. This is 1 because 175 is the maximum value.
Yeah, got it.
Like
So
what these
here,
values tell, like how the income data points are changing, like the range of difference.
no, here also the same thing is there. Low income will get a low value, high income will get a high value. It's just that the range is between 0 to 1. Okay, it's not like that now. Earlier, if someone was having a high income, he will get a low value over here. No, high income will still get a high value, low income will still get a low value. It's just that um, now the range of the variable is between 0 and 1 instead of this being on a different scale and this being on a different scale. Okay.
Okay.
So any distance-based algorithm, normalization is must. We are going to discuss 3: K-means, KNN, and PCA, principal component analysis. For all 3, we must do normalization. And as I said, even in future, if you encounter any distance-based algorithm, we need to normalize. With that understanding, let's now move on to K-means. Okay, how K-mean works is that these white data points that you see are nothing but individual data points. Just imagine as if this is your height, and this is your weight. So we have a chart between height and weight. These white dots represents different individuals. Okay. Now what I want to do is Apurva will answer that later, right? So let's say we have height and weight, and these white data points represents different individuals. What I want to do is in K-means clustering, I want to put similar people together. Okay. Now, when I want to put similar people together, how K-mean clustering works is that we first start with the number of clusters that we want. Okay. Here I have said that I want 4 clusters. Okay. I have said that I want 4 clusters. What I have not answered as of now is why 4? Why I'm taking 4 clusters? Why I'm not starting with 5 or 6 or 3? Okay. But this is a question that I will answer later. For now, let's assume that we know that we want 4 clusters. That is 4 groups we want. Second question that you might have is, how come this cluster is at this we call it centroid? Why this centroid is at this position? This centroid is at this position. This one is at this one is at this. So if you will ask me how I have decided the centroid position, the answer is it is random. Okay, it is a random position. To start with, we put random position to a centroid. And second question, why there are 4 centroids? This is the question that I will answer later. Okay. So let's assume we have 4 centroids and the position is taken random. Okay. In the next step, what we do is for each point, let's say if this is a point, I want to tag this point to one of the clusters, right? I have cluster number 1, I have cluster number 2, 3, 4. I have 4 clusters. According to you, this particular point should belong to which cluster?
1.
1.
Why it should belong to 1?
It's closer to that point, closer to
It
that
is,
centroid.
it's closer to that centroid, right? Very nice, right? And how we know that? Because we are being able to see that, right? But obviously a machine learning technode cannot see, so it will calculate the distance. The machine learning technique is going to calculate the distance between these two. It is going to calculate the distance between these two. It is going to calculate the distance between these two, and similarly between these two. And then it is going to keep the one where I have the lowest distance. So after calculating all the 4 distances, my machine learning technique will know that this point is closest to point 1. So it will tag point 1, this point, to the first point. Similarly, if I have another one, like this one, which centroid this point should get tagged to?
2.
2, right? So what I will do is I will calculate the distance between this point and centroid 1, this point and centroid 2, this point and centroid 3, and this point and centroid 4. Okay, and I will pick the one which is having the lowest distance. So this point will get tagged to this one. Okay, and this exercise I will do for all the points which is there. Let's say, for example, for this point also, I will calculate the distance. And then I will keep the one where I have the lowest distance. So if I have, now this is a question to you guys. If I have 100 data points and I have 4 clusters, so how many distances I will be calculating?
400.
400, right? Because for each point, how many distances I'm calculating?
4.
4, and total number of points are 100.
Yeah.
So total number of distances that I will be calculating is 400. Clear to everyone?
Yes, yes.
Right? So I will be calculating for each point, I will be calculating the distance from centroid, and whichever centroid is closest to me, I will tag that point to that particular centroid. Okay, these are the different points, like the same points that I had here. The same points that I had over here, I checked the distance of each point from different centroid, and whichever centroid it was closer to, I tagged the point to that centroid. Clear? Any question how we are moving from this slide to this slide?
Yes, sir. One question, like what if, one point has equal distance to 2
Yeah,
centroids? So,
right. Happens very rarely, first of all, right? But if it happens, then the answer is random. Because then I don't have any preference, right? Okay. But happens very rarely because here you have only 2 variables, but in general we have multiple variables, right? Then this at the sum coming exactly the same happens rarely, but if it happens, then it's random. Now we are moving from this slide to this slide. How? By calculating the distance of each point from all the 4 centroid, and the centroid which is closest to the point, that the point will get tagged to that particular centroid. Now I'm using a word centroid. What do you think a centroid is? Just by the name of it, what do you think a centroid should be?
Center of a cluster.
Very nice. It should be center of a cluster. Now, let's look at the points. These are the points that I have. Is it right?
Yes.
In this area, I have all the points. But do you think the centroid is in the center of this area?
No.
No, right? Similarly, let's say if I'll talk about these green points. This centroid which is present over here, is it the center of this area?
No.
No, right? And the same logic for here also. This area has all the points, but the centroid is present here. So looks like, although we are calling them centroid, but these points are not present in the center. These centroids are not present in the center. So what we will do is, we will find the new position of the centroids. How do we find the new position of centroid? By taking the average of, let's say, all, like if this is my group, what I will do is, I will add the y-axis value for all the points and take an average of that. Similarly, I will add all the values of x and take an average of that. That will give me the position of the center, the new position of the center. Okay, that is this. From here, I will be moving here. Only centroid is moving. The points will not move. Look at the focus only on these centroids that we have. The centroids will move.
So
So
can
we
you
start.
please repeat that point? Like, how did we find the new center?
So let's say, this particular points, right? X belongs to 3 points. Point 1, that is 1, 5. Point 2, that is 3, 7. And let's say point 3, let's say maybe 3, 9. So the position of centroid will be sum of all the x values, 1 plus 3 plus 3. That is your 7 by 2, 7 by 3. So 2.33. And similarly, the y value is going to be 5 plus 7 plus 9. That is
21
So
by
21 by 3, 7.
that
Okay.
is 7. Okay, that will be the position of centroid.
Okay. Okay.
Okay. Clear to everyone? How we moved from here to here? First of all, how we decided the position of this centroid in the starting? Answer is random.
random.
Right? How did we decide the number of clusters? We will discuss that later. How we assigned each point to these centroids based on distance. Whichsoever centroid was closer to me, I assigned that point to that centroid. But then we realized that these centroids are actually not in center. So we calculated the new position of centroids, and this gave me the new position. But now there is another problem. Can you think of what is the problem with this chart?
I mean, if the centroid is changing, then
Hmm.
the data points and the distance between the data points and the centroid would also change. So the
Right.
cluster would also change.
Very nice, right? So let's say this particular point. Let's focus on this. Earlier, this point was tagged to this centroid. Why? Because this point was closest to this centroid. Now, do you think that it is still closest to this centroid or this centroid?
The third one.
The
Red
third
one,
one.
right? So me tagging this point to this centroid is not correct, right? Ideally, this point should be tagged to red one. And there are similarly other cases as well. This is a very obvious case, but there are other cases as well. I believe this should also belongs to red.
Yes.
right? Maybe this one should belong to this purple one. Okay. So what we will do is we will again change the tagging of points. So for each point, let's say for this point, I will be checking what is this distance, what is this distance, what is the, for us, it is obvious that it will get tagged to red, but a machine learning algorithm cannot see. So it will check the distance from red as well, this as well, this as well, this as well. And then it is going to tag the tagging will change and it will say that, okay, it should not belong to this centroid, it should belong to red centroid. And the same thing will happen for all the points. Can you see?
Yes.
Let's say if you'll focus on only this one. Sorry. If you will focus on this one, I believe this is right. So first it was tagged to some other centroid. Now it is tagged to the red one. Okay, so tagging has changed. But now because I have changed the tagging, there's going to be a problem. What problem is going to be there?
The centroid is not in center now.
Now the centroid is not in center. Because earlier this point was contributing where the centroid position should be. All right. But now this point is not even part of this cluster. So it should not contribute in deciding what is going to be the position of this centroid. So what I will do is the new points that are there, like there are few points which have entered into the centroid, into the cluster. There are few points which has left the cluster. So I will calculate the new position of centroid. See, look at the red one, for example. Look at this red one, how this position is changing. It is moving a little up.
Yes.
All the centroids are changing. That is the new position. Because now there is a new position of centroid. What will happen? There will be a few points
Will leave or
which will
some.
leave and which will join, right?
Yeah.
Like for example here, again the position of centroid will change. Again few points will change. It will keep on happening till we realize that there is no further movement. Okay, so I will now go step by step. Sorry. Now I will go step by step so that we can see that how the centroids are changing. Okay, after this, there is no further movement. So there is, okay, one new position. This is new position of centroid. Now, based on the new position, the points will change the static tagging. Because the points have changed tagging, new position of centroid. Because of new position of centroid, again the points will change tagging. Because the points have changed tagging, new position of centroid. Because of new position of centroid, the points will change tagging and so on. Okay. This is another example. Here I have started with 3 centroids. Again, random positions. It will keep on happening till there is no movement. Right? So this is the final tagging. All these blue ones belongs to one group. All this red belongs to one group. All this green belongs to one group. Okay.
So instead of putting the centroid at a random position,
Mm-hmm.
why don't we first find out for
Mm-hmm.
centroids like based on 3 clusters or 4 clusters?
How
I mean,
should we do that? Sorry.
like first we are putting the centroid at random positions, right?
Uh-huh.
So why are we doing that in the first place? Like we can first find out the centroids and then put it. Like instead
But
of
how will you find out the centroids?
without putting the centroid, we can't make a cluster, na?
Yeah.
Okay.
Right. So, like you are right. Like if it was possible, then I will not do this exercise altogether.
Okay. Okay.
Yeah. Okay, let's say for example this one, right? So we started with this random position, and then you will see that automatically I'm getting 3 clusters. So we never know how many iterations it will take in the starting, right? But the machine learning algorithm is designed in such a way that it will keep on updating till you get to a point when there is no further movement.
Assigning of this, a random centroid also is done by ML algorithm only, I mean, ML
Yes,
technique
yes,
only.
yes.
Okay.
And number of centroids do we need to define at the start, Puneet?
Yeah.
Okay. Yeah, Puneet, if we
Mhm.
don't know how many centroids can it have, so
Mhm.
because we are assuming it have a 3 or 4,
Mhm.
depends on it. So it
Mhm.
will change the right. So is there any way we can find?
Yeah, yeah. I'll discuss that. I'll discuss how we can find the number of centroid. Okay, like this, when you have a lot of data points, these points will be at least 50, 60,000 points are there. And then this is how it looks like for a complex data set. Right? These X that you see is nothing but the centroids. These boundaries means that any point which will be there, let's say for example, if this point is here, then it will belongs to the green cluster.
Puneet, through this we
Mhm.
are finding groups, right?
Uh-huh. Yes.
Yeah, Puneet, I have also heard somewhere that we should have a minimum of 2 or maximum of 5 or 6.
Groups.
Yeah, it should not.
No. Minimum 2 is fine because if you don't have 2 groups, then you don't have groups, right?
Yeah.
So, but maximum should be 5 is I don't think that is correct.
Okay, I saw in some videos that.
See, everything is more like a recommendation,
Okay.
right? Everything is more like a recommendation. It depends upon a lot of things why someone said, let's say, for example, 5. Here only, how many we have? Here we have 6. See, 1, 2, 3, 4, 5, 6. Right? And whosoever created this video, I'm assuming was a very smart guy because I cannot create this. Right? So this guy has 6 clusters, for example, here. Right? Uh, Someone might have said 5. Reason being is that the more the number of groups that you will have, it becomes more difficult to understand what is happening in that group. If you have a lot of groups, okay, then defining that what each group means, it becomes more and more difficult. So it can be a recommendation that keep 5 groups or max to max 6 groups, right? But there is no rule related to it. 2 makes sense because if you do not have 2, then you do not have groups. You just have one, like you have all the population. Okay. Similarly, I feel this.
The points, which are being put at random, I mean,
Mhm.
in the first place, why it can't put in the center somewhere to reduce the number of iterations?
Very nice, Sumit. Actually, that's a very good point. We do that. So
Mm.
when originally K-means was started, so it started with random initialization. We call it random initialization, right?
Okay.
But when I will be sharing the Python code, there I will be telling you that there are multiple type of initialization which can be done. Okay.
Okay.
And
Okay.
one of the type is actually initializing the centroids to those positions where there's more points density.
Okay.
So instead of, let's say, me initializing it, let's somewhere here, like these 4 position, if you look at it, it is not somewhere in the center, it is like outside, right? So instead of doing that, I could have started with here, 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 or here, right?
Yeah.
So that can be done.
Okay.
Okay. But originally when it started with the random initialization. Now there are multiple ways in which you can initialize the position.
Okay.
Okay. Now what this particular example I wanted to cover for a particular reason, right? In this one, the same data points are there. It's just that I am initializing the centroids here and look at how the final position of centroid this is looking like. Okay. When I am initializing the centroid here, then closely observe how the final clusters are going to look like. And then I will, for the same data points, I will show you a different initialization. And then we will see whether the clusters are same or different. See, this is the final cluster. For the same data points now, I will do a different initialization. Same points are there. Just see it once. Same points are there, right? It's just that instead of initializing the centroid here, I'm initializing it here. So what are you expecting? Should we get the same clusters or different clusters?
Different clusters.
We will get different clusters. Actually, that is one problem with k-means. With k-means, the problem is that based on your initialization, the final clusters can change. Here the clusters was different, and here you will see that we might find a different clusters. Is this cluster different from what we got in the first time?
Yes.
Right? See, this particular centroid didn't even get a point. As compared to when I initialize it like this. So this is one problem with k-means, that it is highly dependent upon how you are going to initialize. Okay. Here we got a different set of clusters like this. And here I'm going to get a different set of clusters just based on initialization. Okay, any question? This is again the same set of data points, but different initialization. This time I will get a different clusters. Again, different initialization, different cluster. That's what we are trying to show. So yeah, so this is related to first initialization. This was the clusters. Related to second initialization, this was the cluster. Related to third, this was the clusters, and so on. Okay. Any question?
Which one is correct?
All are correct. There
All.
is no way we can say that this one is better, the other one is not. Okay, all are correct. Yeah, but one drawback of k-means.
Will that impact the accuracy of the model?
There's no accuracy acceleration in case of unsupervised machine learning technique because there's no target variable to compare it with,
Okay.
right? So there is no accuracy. We cannot know whether it is a good clustering or it's a bad clustering. It is just clustering.
Okay. Okay.
Here the compilation time increases, like
Mm.
depending on
As
the initialization points.
not, yeah, it will because the number of iterations can change, right? But not vary a lot. Like it will not be like that one is taking 50 minutes, one is taking 5 minutes. It can happen that one is making 5 minutes, another is taking 6 minutes, 7 minutes. Okay, so it can vary, as you said, because in each initialization, I'm taking different number of iterations to reach to the final group, but it is not going to change a lot.
Uh,
Mm-hmm.
are you telling there is no way to test like a particular clustering is good or not? Then how will decide? Like,
We cannot actually. In clustering, there is no way in saying that this one is better than the other. Okay. But there is one method in which you can directionally think about it, but let's discuss that after the break. Okay.
okay, but testing should be like should be do right. Say you are
Mm-hmm.
say, as you take an example Amazon. So
Mm-hmm.
age and income and spend, right? So so suppose you did some clustering and which is not good, then we'll lose revenue, right? Or something. So we should be able to. I know this
Mm-hmm.
algo don't have this model don't have the. I think this
Mm-hmm.
is too complex because so many data point and all. But
Mm-hmm.
uh,
No,
in the
no, okay. We'll discuss. We'll discuss after the break. Okay.
yeah.
Cool. After the break, we will discuss how we will decide the number of clusters. That is one thing. And second thing is we'll come back to this. So based on our next discussion, we can come back to this and see that which one do you think you're going to prefer. That's it. Okay. Cool. We'll see you guys in 15 minutes.
Okay.
Okay. So we were discussing that one thing which is pending as of now is how we can identify the number of clusters. Okay. So let's focus on that. Let's try to understand it using an example. Mm. We think this one's. Yeah, okay. Now let's imagine we have multiple data points. Okay, I am intentionally taking a data set where it is very clear to us that how many clusters should be there. Okay. Now let's start with So, okay, how many clusters should be there in this data set?
4.
4,
4.
right?
Clusters.
4 clusters should be there. It's just that we don't know it yet. Like after seeing it, we know, but a machine learning algorithm cannot see, so it doesn't know that there are 4 clusters which are possible. So how we are going to decide, especially when there are more than 2 variables? There are 2 variables, and I know that it is going to be 4. What if there it was 3 variables? Then it will be 3D. How would we know that? When there are 4 variables, 5 variables, it will be in 5D. How we will know that? So let's try to understand it through an example in 2D, and the same theory then will apply to 3D, 4D, 5D, 6D as well. If I will start with, only one cluster, okay, where will you put the centroid? Here, approximately, right? And then what I will do is, I will calculate the distance of each point from the centroid. Similarly here also. For all the points, I will be calculating the distance. Okay. And for cluster number 1, when I have only one cluster, okay, I will be checking, I will be taking the sum of all of these distances, okay, or let's say average distance, because that is like more easy to visualize. So I will be taking an average distance, and that average distance value will be maybe somewhere here. Is that right? Fine so far, no problem. What I'm doing is I'm just adding the average value. And this WCSS that we have, this is nothing but within cluster. Within cluster sum of square. WCS, it is nothing but the distance, the addition of distance from centroid to each point. Second thing we will do is, we will put 2 clusters. If I need to put 2 clusters, where should I put it? Can I put it like this? One cluster like this, and one cluster like this, right? Because I need to find something in the center. And similarly for this. Now tell me if the average distance will increase or decrease between this
Decrease.
and this.
Decrease.
Decrease, right? So more or less like this. So it will significantly reduce. Maybe something like this. Now, if instead of 2, someone said that I want 3 clusters, then how it might look like? Maybe this one remain the same. and I will have like this. Now, will the distance reduce or not? Like from here to here, right? It will reduce further. When I will make it 4, in that case, what will happen is I will have one here. I will have one here. Will the distance reduce?
Yes.
So the distance will reduce further. Now, what will happen next? If I will make one more cluster instead of 4,
It will increase.
okay, let's see. Maybe let's put it here. Let's say one cluster is here, one cluster is here. Sorry, not like this. For this cluster, it will be something like this. So the average distance that we had over here versus average distance that we had over here, will it increase or decrease?
It will be almost similar, not much change.
But will it increase or decrease? I agree with you.
Can't say anything.
It will decrease actually.
Okay.
It will definitely decrease. Just look at
Points
the
use.
here, right? Don't you think it will decrease?
Yeah, it will decrease.
It will decrease, but as you said, it will not decrease much. So it will be more or less same, but will decrease.
But WCSS, like how are we calculating it? Are we calculating for all the clusters or only?
No, for all the clusters, the distance of all these, this it is a summation of distance of each point from the centroid, or it's from its respective centroid.
And we are doing it for all the centroids, I mean, for all the clusters.
Yes.
Okay.
Okay. Now let's say if I will add one more cluster to this, how it will look like? It will look something like this. Maybe like this. So these points maybe get tagged to this, and maybe this point will get tagged to this. Right? So between this and this, the distance will reduce further, right?
Yeah, minor.
But minus change, as you said, right? Here. And so on. Now, even if I'll add one more cluster, the distance will reduce, but won't reduce much. Now, if I make a curve, the curve will look something like this. Is that right? So till cluster number 4, there was a sharp drop in WCSS after each item. When you are adding one more cluster, there was a sharp drop in the distance. But after the 4th one, you will see that the distance is not decreasing much. So if I would have to put it in a new slide, this is how it will look like. Okay. This is WCSS. This is number of clusters. Okay, like this. And what will happen is from as we are moving from 1 to 2 to 3 to 4, with as we add more clusters, there will be drops, like good drop in WCSS. But after 4th, there is not going to be much of a drop. The drop will be there. As you will add more cluster, it will always drop. But the drop is not going to be much. So this is how the graph will look like. Okay. We can see that at point 4, the number of clusters 4, right? The rate at which the WCSS was decreasing has changed. Okay. And this point is called elbow point.
What did WCSS stand for?
Within cluster sum of square. Okay. This is nothing but elbow point. And this will be my optimal, like this should be the number of clusters that I should choose. Okay. How it will look like, let's say, let's do a Google WCSS. And this is how in general it looks like. Okay, so this, like here, for example, this point, the number of cluster 3 can be taken as the optimum number of clusters. Like this. Okay, sometimes it is very straightforward like this. Sometimes it is a little complex as well. Okay, like here it is straightforward, but sometimes it is little complex. Let me show you if I get, yeah, like this one only, right? Here, whether you will be keeping it at what it is 3, or should I be keeping it at 4? Like some doubt can be there. There is not very clear elbow point which is there, right? But we know that it should be somewhere between 3, 4. Here you can see that maybe there are 2. So this kind of a graph is also called elbow curve because the shape of this graph looks like elbow. So if I search for elbow curve, okay, this point looks like an elbow. So if someone asks you how you will decide the number of clusters, simple thing is by elbow method or using elbow curve. Any question?
We are defining groups by using the distance, right?
Mm-hmm.
Like how we know what are the data points in each of the group,
Where
like like what it considering, I mean what data types it considering and making as a group, like,
Here you are asking that how would I know that which point belongs to
No,
which
no,
cluster?
no.
Huh?
These
Uh-huh.
data points, what it belongs, like which data point, how this make a group, that I'm asking.
Which red points are you referring to, or which points?
Which data points? Like we take an example like income and spend.
Uh-huh. Right.
Like what these points tell, like red points.
Yeah, you can assume anything. Like, okay, income and spend maybe. Okay. Height and weight can be there.
And also the age.
Yeah. Age can also be there. Age and income can be there. Age and spend can be there. Anything. Okay. Any other question, anyone?
Puneet, in supervised learning, we know the number of clusters, right? In unsupervised, you will be not knowing. Or is it both, it will be the same?
Clustering is only in unsupervised learning. We
Okay.
don't have clustering and supervised.
Okay, there is no clustering in supervised. Okay.
Yeah. Right. Clustering in itself means unsupervised learning. Okay. Any other question?
Like for this graph, you kept the spend and income. Through this, we can predict the age.
It is not to predict the age as such. It is to understand the clusters, like the age thing that I talked about, right? I was just saying that if you want, you can build that kind of an understanding. Okay, but it's not like that I'm doing this exercise to predict the age. Okay, but I'm just trying to build the understanding of the clusters.
Like here, we get the what each cluster has what age group.
This is our guess. We don't know. This is what my guess is. I'm just saying that most probably this is going to be the age group. I don't know that. Okay, cool. If no question is there, we will try the k-means clustering in the Python. Just 1 minute. Let me see which code I'm using. Okay. Please upload the code and download the file. Okay. I have this data set. In this data set, we have like a few columns like customer ID, gender, age, annual income, spending score. And if we want, we can take all of these variables to do clustering. Okay. But I will be using only two variables here. Why I'm using two variables? Because I want to visualize how the clusters will look like. Okay. And to visualize it, I can only visualize it in 2D. To have it in 2D, I can only take two variables at a time. But yes, when doing clustering, we can take many variables. But if you want to visualize, we can take only two variables at a time. Now, what I've done is, this is what my data set is. I have gender, age, annual income, spending score. Quickly go to the main part. There is no missing value in this. So I have taken age and income. Okay. I have taken age and income as two variables based on which I will be doing the clustering. Now to find the optimum number of clusters, what I will be doing is I'm trying out all the values between 1 to 30. Okay, I'm taking cluster as 1, 2, 3, 4, 5, 6. So I'm trying it till 30. What I will be doing over here is I will be creating a graph. So I'm using k-means clustering. My number of cluster is, let's say, I. This is what I was telling you later. Let's say you can write a for loop, right? And you can change the value here. And every time, like when I will have number of clusters as 1, what is the value of WCSS? When I will have a number of clusters as 2, what is the value of WCSS? So with each loop, I'm storing that value. Okay. So with each loop, I'm storing that value. And in the next part, I'm simply plotting how the WCSS value looks like with number of clusters, right? As I was telling you, right? It might look very clear that, okay, 4 is the inflection point, or in this case, for example, 3 is the inflection point. But in real life, sometimes it looks like this. No, I'm not sure whether it is, I should be taking 4 clusters or I should be taking 5 clusters. Okay, so 4 is also a right answer, 5 is also a right answer, right? No one can say like the 4 is better or 5 is better, but at least now we know that we need to choose one value out of 4 or 5. Okay, so what I have done is I have taken 5 as my number of clusters value. Okay, number of clusters is 5 based on this chart. Okay, can you please run the code till this point?
So the output isn't same in my case. And
It should
there
be.
are code changes also. Like I don't see that before scaling and all that.
Mm, okay, anyway, that's fine. If it is not there, it's fine. Just follow my code for now. Okay, I will share this code directly.
Okay.
Mm-hmm. You tell me. Okay. Now, what we are gonna do is, okay, guys, if your code is a little different, fine, leave it for now. Focus on my code, and maybe I will share my code with you guys. Now, what I'm doing is I'm taking number of clusters as 5. In it is nothing but initialization. Okay. The initialization can be random as well, which was the like the base case. And it can be k-means plus plus. What is the meaning of k-means plus plus here? It means that instead of doing a random initialization, initialize the centroid in such a way that most of the centroids are at uh, uh, dense areas where there are more number of points. Okay, so instead of randomly initializing it, initialize it in such a way that the centroids are at densely populated part so that the number of iterations will be less. Okay.
Can you repeat it, please?
I was saying that instead, like one initialization that we have discussed is the random initialization. So you can randomly initialize the centroid, or you can initialize the centroid in such a way that wherever there is more dense area, let's say, for example, here, if I would have to initialize the points here, either you can initialize it like this, you know, that these are the four centroids. This is one way. Or what I can say is, instead of initializing it like this, I can say that wherever there is more point density is more here. So one initialization can be here. 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 So wherever there is more point density, initialize it there. Okay, so here it is going to take less iteration to reach to the final cluster. Make sense?
Yes.
Okay, clear to everyone? Right. So instead
So
of doing
please
random,
explain once again. I didn't.
okay, so there are two types of initialization that we can have.
Yeah, the random and the k-mean plus.
Yeah. So let's say if I'm randomly initializing, then the points can be anywhere, right? It can initialize here, here,
Yeah.
here, and let's say one is here. Is this kind of initialization better, or this kind of initialization is better? That where what I'm doing is I'm looking at the density of the points, and wherever there is more density of points, I'm saying that, okay, this area looks more dense, right? So maybe one should be here. This area looks more dense, so one should be here. This area looks more dense, so one should be here. This area looks dense, so one should be here. So in which
Yeah.
case you think that it is a better initialization, this or this?
Second case.
Second case, right? So initialization equal to k-means exactly the same thing. That
Okay.
where instead of randomly initializing, initialize smartly. And how it smartly initializes based on points density.
Yeah,
Okay.
got it.
So we have done that. After this, what we are doing is we are plotting our points and our clusters. Okay. We are plotting our points and our clusters. So these points that you see, gray points belongs to one cluster. These blue points belongs to one cluster. These orange points belongs to one cluster. Yellow to one, green to one, and so on. Okay. Okay. Any questions so far? Now tell me, is this clustering making sense to you or not?
Yeah.
Making sense, right? If I will focus on a few points like this, the clustering of this point, is it making sense to you or not?
No.
Why?
It is more closer to the cluster one, which is yellow, this point.
Mm-hmm.
And I believe
Mm-hmm.
it's not making sense, to be honest.
Right, exactly, right. For example, this one looks more close to orange,
Yeah.
but I'm tagging it to blue, right?
Yeah.
Doesn't make any sense. This yellow one looks more close to green, but it tags to yellow. This orange looks more close to yellow, but it is tagged to orange.
Yeah.
So at a very high level, these clusters are making sense. But whatever our understanding is, from that understanding perspective, these clusters are not making sense. Okay. Why that is happening? Because we missed a very important step while doing clustering. What is that?
The position of centroids, taking the
Hmm.
means of the each and every data points after making the clusters. Then
That's not the problem, because the algorithm that we have used, right?
No,
That will
we
take care.
didn't do normalization actually.
Yeah, exactly, right? So first I'll answer his question. So yes, the means part is something which is already taken care by the algorithm. We need not to do that.
okay,
Like all the iteration, the machine, the function has already done on its own,
okay.
right? When we use k means this one, so it has already done all the steps on its own. And the problem is that the data set that we have provided, the data set is not correct because we have not normalized it.
Yes.
Okay, if you look at the income and age, the scale is different. Age is varying between 20 to 70. Annual income is varying between 20 to 140. Okay, so whatever is having the bigger scale, that is going to have more impact. So what we need to do is we need to normalize it so that the scale of both age and annual income is same. Okay, so in the next part, what we will do is we will scale the variables. Okay, this is min-max scalar. Min-max scalar is nothing but exactly what we had discussed earlier. Just like,
Puneet, whatever you shared in that, it is not there, please.
yeah, I'll share the updated code after this. Okay. So min-max scalar, using min-max scalar, I will be scaling the variables. Okay, and then I will be doing the clustering. Okay, so here what I'm doing is in these three, I'm scaling the variables, and then the data set that I have, scale data set, that data set I will be using. Okay, now let's plot the points. Now tell me, is it making much more sense as compared to what it was earlier? Can you find any point now which is not making sense?
No.
No.
No, right? All the points are tagged to the nearest centroid. Okay, so it is very important to scale the variables. If you will not scale the variables, then we will have something like this, which is not correct. So very important step. Very important step in any algorithm which is based on scaling, which is based on distance, to scale the variables. Okay. In the next part, what I'm doing is I'm nothing but just giving each point a tag, whether it belongs to cluster 1, or it belongs to cluster 2, or it belongs to cluster 4, and so on. And this is nothing but position of centroid. We have 5 centroids. This is nothing but position of all the 5 centroids.
Puneet, the
So,
min-max scalar function, what it will do is the
mhm,
normalization of the
yeah,
data points.
yes.
Yeah, exactly. Okay.
Yeah.
So, Puneet,
Cool.
we have the centroid, so if we can calculate what are is that a new point will be in that positions or not, right? Is it associated with the cluster? Which cluster?
Yeah, right. Yes.
Can you scroll a bit above and before
Hmm.
the 22? Yeah,
Tell me where you want me to stop.
yeah. This one, 20. Yeah, 20.
Mhm.
So this min-max scalar is the function for uh, normalization.
Right. Yes.
Okay.
And Puneet, what is this k means of init? K means plus plus. What are the other things are there?
One is random. You can randomly initialize, or you can use k-mean plus plus. K-mean plus plus means that you are initializing a little smartly instead of doing the random initialization.
Okay.
Can you explain like the 20th, the first three line? Like what are we doing exactly? First line
Yes.
is doing standardization. Then we are
No, no,
fitting
no,
the
no, no,
model.
no, no. First line is just declaring the function. We are
Yeah, yeah.
not doing the
First
standardization. In the second line,
normalization.
we are normalizing.
Yeah. So why are we using that X scale too?
Actually, it was not needed, to be frank. In that case, I would have to, I can just write this much from here to here also.
Okay, okay. Okay.
Because there is no use of X scale too. It is not used. Only used X scaled.
Okay, just one minute. Let me check. Okay, by default, it has only 2 columns. Let's see why. Okay, Excel, yeah, okay, I might have realized later.
Use the X only. Just X.
Okay. Right. Because X already had, I think, only 2 variables.
Yeah.
Right? Yeah, you were right, actually. Yeah, you are right. This one is not needed. This one is not needed.
Can you go back to that code, please? Line number 11, what does it indicate in the 25? Like, why are we doing?
Line number,
Out
which
11 in 25 block.
25 blocks, yes. Line number
11.
11.
Yeah.
So what we are doing is here again, here we are just initializing the function. Just like, let's say, for example, what we did over here, right? We are just initializing. We have not provided the data set yet. Here
Yes.
we are using this function later to fit the data set. Here we are providing the data set.
How the Y came in scaled values look like? Can you please print and show once?
Yeah, sure. It will look like just there will be one more variable, I believe, that is cluster. Yeah. Which cluster it belongs to, each point.
Okay. Got it. Yeah. So there below you have used some methods like inertia and all that. So that will give us the cluster name for each point.
Where is the inertia part?
Yeah, I think it's below.
Below this, okay.
Yeah. Yeah, this one. Not inertia, I believe.
Are you referring to this code 22?
Yes. Yeah.
Yeah, here we are just not doing
Labels
anything
and
but just tagging, giving cluster to each point. That's it.
okay.
And Puneet, what is random state 42?
A random state is like we've discussed it multiple times now, right? Random state
Randomly
is
assigning data points.
yeah. So random state means that so that you and I will both get the same answer. The random state you can keep it like 42, 500, 80, 100, does not matter. It's just a random number.
Okay.
As long as it is same for you and me, we will both get the same answer. Why I'm using random state equal to 42 here? Because the initialization that we are doing, that is random. Even in k means plus plus, we are just doing a better initialization, but it is not fixed. Okay, so that we both you and me get the same initialization of the centroid. That's why we are using random state equal to 42.
And also, Prince, can you please explain the lines of codes? I think like you're scrolling faster.
Okay, which line of code?
Generally, I'm asking.
Acha, okay, you are
Steps.
asking in general. Okay, got it. We'll keep it in mind from next time. Yeah. I thought you were asking for a particular kind of code.
And like while visualizing the clusters,
Mm-hmm.
so why k means scale 0, 0, we have taken the 0, comma 1.
Yeah, right.
Can you please explain that? Like, what is it exactly?
Mm.
Line number 4
Yeah.
to
No.
9.
I can see that. Mm. This part I'm being able to understand why I have done 0 for this. Mm. Is it not the first column, I believe, if I'm not wrong? So what I'm doing is I'm filtering my data set. So I'm filtering my data set. I'm saying that wherever the label is 0. So after doing this clustering, we got the cluster numbers, right? How many clusters we have? We have 5 clusters,
5
right?
clusters.
1, 2, 3, 4, 5. But instead of, let's say, those clusters labeled as 1, 2, 3, 4, 5, it starts from 0. So we have 0, 1, 2, 3, 4. Okay, still 5. It's just that it is starting from 0. And 0 over here represents the column number that I
Okay.
want column number 1. Okay. And here the 1 will represent what? Column number 2.
Column
Right?
number 2. Okay.
Right, exactly. So I'm filtering for this condition that wherever k-mean scale is equal to 0, it means that wherever my cluster number is 0, give me the second column. Okay, and that will become my y. What is my y here? That is income. Okay, and here what I'm saying is from the same data set, X scale data set, wherever your cluster number is 0, give me the 0th column. What is 0th column here? Age. Okay, and that is going to become your X. Is it clear, Sumit? No?
Yeah, it is clear. Yeah. So we are plotting all the intersection points of age
So
and the other x-axis and y-axis for
right.
cluster 0, 1, 2, 3, 4. Yeah.
Exactly, right. And we are
So,
doing it one by one because we wanted to give everything a different label and a
Hmm.
different color.
yeah.
Can you explain this line of code with the diagram below?
This one?
Yeah, the above code. Just now I explained it.
This one, right?
Yeah, the colors yellow, blue, green.
Colors yellow means that it will be of yellow color.
I mean the
This,
code line 4, 5, 6.
yeah, it's nothing but SNS is your library. Scatter plot is a function. This is the X values that we have. This is the Y values that we have, right? And using these points, so these points I want to plot it on X. These points I want to plot it on Y. I want to keep the color as yellow. Okay. The label is going to be cluster 1. And S equal to 50 is nothing but size. You can change the size from it. Let's say, for example, I can make it 100. So the yellow ones will become a little bigger as compared to, let's say, the orange one. Okay. Like maybe if it is not visible, let's say 200. Okay. So size will change. So S is the size.
That how we taking a group of points as yellow, blue, green color. How the variation.
Because I'm filtering this data. So whatever the data is filtered, like whatever the data which is filtered based on this condition, that will be yellow. Whatever the data will be filtered which is based on this condition, that will be blue, and similarly gray, orange, and green. And what is this condition? This condition is nothing but cluster number. Any other question?
So, Puneet, at last, what we are getting is the position of centroids.
Yes, right. Yes.
Okay. And does it make any, I mean, does it call for any interpretation of the data? Does this mean anything to the data right now?
No, nothing actually. It's just that let's say tomorrow if you'll have a point, you use that point, see what is the distance of that point from each centroid, and then based on that you can calculate whether it belongs to cluster 1, 2, 3, 4, or 5.
Okay. So these positions will be used for calculating distances.
That's one of the ways it can be automatically calculated, to be very frank. I need not to manually do it, but this is just for visualize. This is one of the I would say variable which is present in this k-means scale. So if I will do this kind of a thing, right? So it tells us what are the different different columns, or let's say variables which are present, right? So I've just written that, okay, cluster center is something that you can also get it from this if you want, the position of the centroids. How it can be important is in some cases, like if you're trying to do something like, sometimes people use k-means clustering to find the position of new stores. Okay, I have a data set. In that data set, I want to see like this gray area that you see. Just imagine it is a map. Okay, and these data points, this blue, gray, these data points are nothing but where your each customer is living as of today. Can you visualize it in that way?
Yeah.
This is a map, and these data points that you have, these dots are nothing but where each customer is living as of today. Clear?
Yeah.
Right? Now imagine I want to open 5 stores, and I want to see that if I want to open 5 stores, which will be the position in what should be the store positions. So I can use k-means clustering to see that if I want to open 5 stores, what should be the position of those 5 stores, so that I can I can cater to maximum number of customers, so that the customers not have to travel a lot, right? What should be the position? So these centroids will be nothing but position of those stores.
Okay.
Right? In that case, I want to know the position of centroid.
Understood.
Okay.
But we can still, I mean, we are saying that this is unsupervised and it doesn't have a target variable, but this, let's say the example of stores that you have taken, this Android seems like a target that we want to achieve.
Right.
So is it fair to say that it doesn't have a target in unsupervised?
No, right. It is fair to say it doesn't have a target, because when we say target, the target should be present by default in the data set. So is this location of stores, for example, was present by default in your data set, or is it something that you have found out later? We have found out, right? So the target that we talk about, based on which we divide the data machine learning techniques into supervised versus unsupervised, okay, that target should present by default in the data set, not something that you are calculating using machine learning. So right now you are calculating this position using machine learning technique. Okay, so
Understood.
if the target is present before even using machine learning technique, then it is supervised learning, otherwise it is unsupervised.
Okay, sure. Probably one more question, Puneet. When we started this k-means, you took one example of height and income. And they've had a different scale, then we normalized and brought on a single scale of between 0 to 1.
Right.
After that, what does it mean? I mean, how do I tell that which one is similar. Like we were talking about guy 1 and guy 3 being similar, right? Logically, by seeing it was looking similar, but from that, after bringing them to the same scale, how do we tell that 1 and 3 were similar?
No. So after bringing it to the same scale, it's not your job to kind of manually go through things and say that this one is similar, this one is not similar. All we will do is we will calculate Euclidean distance and see whether guy 1 is more close to guy 2 or guy 3 based on Euclidean distance. Okay. I was saying that if you will calculate the Euclidean distance now, you will see that the guy 1 and guy 3 are more close to each other as compared to guy 1 and guy 2. Okay. So, but if you just look at the value and ask me that whether guy 1 and guy 2 are more similar or guy 1 and guy 3 are more similar, I don't know. But once I will calculate the Euclidean distance, I will know that guy 1 and guy 3 are more close to each other.
Okay.
Okay.
Yeah. Sure. Thank you.
Yeah, sure. No problem. Okay, that's all for today, guys. I will share the PPT that we discussed yesterday versus what we have discussed today in the share drive along with the codes. And I'll see you guys next week. Next week, we will try to wrap up the machine learning part. Mainly three major machine learning techniques which are pending. One is KNN, K nearest neighbors. One is your PCA, that is principal component analysis. And other one is SVM, that is support vector machines. So K.
So this one, this some naive basis base something is there, right?
Naive base, yeah, we will also cover. Okay. So naive base is very straightforward, like half an hour max to max we'll spend on that. So yes, you're right. So naive base, KNN, your what was PCA and SVM is pending. So naive base very straightforward, very easy. KNN very easy. PCA is a little difficult, but along the lines of what we have covered so far, not something very high fundo. But SVM is going to be the one where let's say it is a little difficult to understand, but we will see. We will see on that. But at least for the remaining 4 or 5, whatever is remaining, we should be able to complete all next week. If we will not be able to complete it, then it might spill over to the next to next week part. So we will see. But most probably, I'm expecting that it will get completed next week. Then the remaining 4 or 5, whatever is remaining, only one difficult one is there. That is support vector machine. Otherwise, others are very easy. Like for example, I hope the K-means one, you must have found it interesting, and I hope it was easy to understand as well, right? Nothing
Yeah,
some high
yes.
do mathematics and all, right? So the same thing with the remaining ones as well, except SVM. So we will see all of that next week, and till then, bye-bye.
Yeah, Puneet, one question. Actually, do you have any documents to go through that one, to go through, because to recover that one. So actually, if you share some documents, right, that would be helpful to go through.
I can recommend a few books, but my suggestion will be go through the slides, go through the recording, and based on that, let's say a few of you are trying to use ChatGPT, Google, and all of that. I always recommend that, right? So whatever we are covering in class, try to Google it, try to use ChatGPT, try to learn more about it. That will be a better way of learning as compared to like referring to some book. But yes, if you guys want, I can refer a book as well.
Sure.
Okay.
Sure.
Hi.
Cool. Thank you. Bye-bye.
Hello.
Yeah, tell me.
Like, can I know like when we'll work on real-time projects? Like,
so once we are done with the theory part, right? Then the projects will start, and we will have different instructors for different projects. So it need not to be just me who will be taking those classes.
like it will be after machine learning or it will be like after AI?
It depends, Rahul, to be very frank. I'm not very sure on this. Sometimes it is after machine learning as well. Sometimes it is after deep learning, depending upon availability of the tutors. So not sure, to
But
be
it is not
honest.
like after the end of the course or anything.
If it is after deep learning,
Okay.
will it not be after the end of the course? Like, is there any other module which is pending?
Like,
Generative AI is also based deep learning.
Yeah, deep learning and generative AI both are same.
Okay.
and Excel is there. Excel, Power BI,
Power
Okay,
BI,
okay. Yeah,
Excel,
yeah, yeah. Right,
Tableau.
right, right,
Tableau.
right. So ideally, it should be after deep learning in that case, if these many modules are pending.
It would be better, sir, like if we complete, machine
Hmm.
learning projects
Mm-hmm.
soon after we complete the theory part. So
Mm-hmm. So, Mit,
it
actually, this is the good part and bad part of this thing, right? That if we are planning to get people who are, let's say, actually working in some company and we want them to take project classes, it depends a lot on their availability as well, right? So, if I think from Abhishek's perspective, he tries to get in contact with these people, he has contacts with
mm.
them, but they can also say yes and no, right? On the other
So
hand, we
would it,
can, oh, yeah, tell me.
sir, would it be not you? I mean, because you have taken the ML classes, right? So it would be
No,
better if
no,
you take the
actually, no,
projects.
no, no. So what we try to do is that, like, see, Sumit, you might have
Mm,
liked or might not have liked my teaching style, right?
mm,
So what we try to do is that if someone is taking one part of it, someone else should take some other part, like the other part of it. So if I have taken the ML part, in general, we prefer, there is no guarantee although, in general, we
mm.
prefer that someone else should take the project part so that in case someone might not have liked my teaching style, you might like the other person's teaching style. Or if I might have missed something, the other person should be able to cover that, right? Because everyone has different experiences to share. My
Oh,
examples might become repetitive over time. So it's always better if we have different tutors who take different projects. But as I said, right, because everyone is a working professional, it depends a hell lot on everyone's availability.
okay, okay, okay.
Okay. Cool. Thank you guys. We'll see you next week. Bye bye.
Thank you. Bye.